We are on section 11.8. This is volumes of pyramids and cones. Now, yesterday we did volumes of prisms and cylinders, and yesterday we said, hey, it's pretty easy to find the volume. All you need to find is the area of the base, and then multiply it by the height between the bases. And it's like stacking up areas. That's all it is. We got a prism. It's like a trapezoid, and we stack another one and another one and another one on top, and we create a three-dimensional figure. So volume is really just the sum of all the little areas. All right? You add up a ton of areas, you're going to eventually get to a volume in a 3D shape. So today we want to know, well, what's the, how do pyramids and cones relate? And so I have a little visual aid for you today. What am I doing here? Here we go. Nope, not that one. That one. And this one. Okay, here we go. I found what I needed. Okay. So here's this, what is this? A prism. This is a square-based prism, also known as a cube. Okay. You'll notice that I have a pyramid here. So my pyramid is has the same base size as the cube. And when we look at them, they are the same height, top to bottom, okay? But so you can see that they're like the same size, and they have the same size base, and so pretty similar, all right? So the question is, how many pyramids? I'm going to fill a pyramid with water. I'm going to fill this pyramid with water. How many pores of water do you think will fill up the cube? Two, three. Give me some fingers.
1/3.
4, 3, 2. All right. So I'm filling up my pyramid. All right, ready for this? 1. Oh. And another one. Anybody changing their answer yet? 2.
That makes sense, because like 1/3.
All right, so there. I got filled a little over, but yeah, a little bit. Yeah, I know, a little punchline first there, but 3 pores filled up my cube, which means then if I say, well, how much, if 3 pyramids fit inside the cube, how much of one cube actually fits inside the pyramid? 1/3. And that's where the 1/3 comes from. And so, sort of gave it away. Didn't intend to do that though, but and so what it is we have the same exact formula, area of the base times height, except the shape that comes to a point, it's just 1/3 of that volume, okay, which is kind of interesting. And so here, let's do a couple of these. To find the volume of the pyramid, I need the area of the base. And again, the area of the base, here is our little base. What shape is our base?
A square.
Not a square. Rectangle. It is a rectangle. And how do we find the area of that rectangle? Base times height. So edge times edge, 10 times 11. So 10 times 11 is 110. And then if I want to find the volume, it is simply 1/3 times the area of the base, which was 110, times what's the height of my pyramid? 16. So that is the height straight up to the point, which is 16. All right, so I'm going to use my calculator. So I'm going to type in 1/3 times 110 times 16. And I get 586.67 inches cubed, because they're talking about volume. All right, let's look at number 2. Again, it is a pyramid, so I need to know the area of the base. And what shape is the base?
Rectangle.
Rectangle. So we're going to find the area of the base, which is just base times height, edge times edge. So 21 times 9. Thanks. 21 times 9, 189. Totally correct. Good job. All right. I don't have the answers for these, so that's why. I'm just making sure. Volume of anything that comes to a point is 1/3 times the area of the base, so times 189, times the height. And what's the height of our pyramid? 5. And again, that's the height to the tippity top of the point there. So a height of 5. All right, so we have 1/3 times 189 times 5. And I get 315 yards cubed. So it's really kind of convenient that the volume formulas are quite simple. Just area of the base times the height. Does it come to a point? And if so, then we need the 1/3 on there. Okay, so really, really nice. Let's look at number 4. All right, number 4 is a triangular based. Oh, number 3 is really good. Number 3 is really good. Hold on, I need to see what the homework is today. Yeah. What do you have to do on number 3? Yeah, we don't have that straight up perpendicular height. So I like this one. I think we're going to have to do this one just because I was like, ooh, that's good. All right. So we don't have the perpendicular height that comes to the tippity top. We're missing our perpendicular height there. Well, we have a slant height, but that doesn't help me. What do we need to do?
Divided by 2?
Divide what by 2?
25.
No. Divide 14 by 2. So you were close. There is a right triangle in here, ladies and gentlemen. Do you see the right triangle? Oh, okay. So I'm going to call that X. Oh no, it's not X. What is it? It's not X. It's 7. Yeah, it's 7 because it's half of 14. So we can use that 7 to help us with our Pythagorean theorem here. So leg squared plus the height squared equals our slant height of 25 squared. So what do we need to do to solve for H?
1 squared, 7 squared, plus 25 squared. No.
Wait, 7.
14, no.
So wouldn't it be like 25 to the power of 2 minus 7 to the power of 2?
Yes.
And then you do the rest?
Yes, we need to subtract 7 squared, so 25 squared minus 7 squared.
Man, I'm going back to the
and then take a square root of both sides, and we get that the height is 24. Ladies and gentlemen, that is a Pythagorean triple, 7, 24, 25. That is a Pythagorean triple that happens a lot if you see a right triangle. There's a few more, like 3, 4, and 5. There's another Pythagorean triple, just ones that work out real pretty. Nice numbers, no decimals. All right, so our height is 24 feet. And now we can go about finding the rest that we need here. So the volume is area of the base. And what shape is our base? A square. So I need to find the area of that square, which is just going to be base times height, or 14 times 14. 196? Yep. All right. And then if I want to find the volume, it is going to be 1/3 times the area of the base times the height of 24.
It should be
1567?
No, 68.
1568?
Yeah.
Is that what other folks got? Yeah? All right, feet to the third power, cubic feet, because that would be a big shape that is a foot by a foot by a foot cube, a foot cube, yeah? True, but that's for area, yeah, and so, like, when we do a square foot, like, it's just, like, here's 1 foot by 1 foot, but when we turn it into volume, then we go up with that foot, all right? And so we get 1 foot here to create that volume shape, all right? So, yeah, that's how it turns into volume. Okay, let's look at number 4. This is a triangular-based pyramid. Triangle base, so once again, same formula. I need to find the area of my base, and I can see all my information on my base right here. What shape is the base? Triangle. And what's the formula for a triangle? 1/2 base times height. And so we have a 1/2, and then our base is 12 millimeters. And what's our height of our bottom triangle? 7.5, yes. So 6 times 7.5 is 45. Do you see how I did that? Where'd the 6 come from? Half of 12, yeah, okay. All right, and so then the volume is going to be 1/3 times the area of my base, which we said was 45, times the height of our pyramid, 10. 1/3 of 45 is 15, yeah, times 10 is 150. Awesome. 150 millimeters cubed. Rad. Okay. Do you have questions for me? Pretty easy, right? Okay, turn the page. Oh, are you done? Here, sorry. There we go. Good? Got it? Okay. All right, last couple here. Well, do you want me to show you how the cone relates to the cylinder with water? Yeah, just so you can see, because, you know, I don't do this very often. It's like visual. Okay, so now I got a cylinder, and I have a cone, and they have the same size bases. They match, so the bases match. And they are the same height, exactly. So these are related solids here. And so we want to know, again, if I fill up the pyramid with water, how many pyramids can I pour into the cylinder? What's your guess?
1/3.
Well, no, but 3. 3 little, this is clearly smaller than the, right? So more of this should pour, yeah. So let's see. So we're guessing 3 because they sort of gave the, I meant to cover that formula up is what I meant to do, but I forgot. All right, there's 1 pour. Here's my second pour. And I should be a bartender. Oh, no, total fail. Okay, but how many pours? 3. All right, which means if I can pour 3 cones into my cylinder, how much of the cylinder goes inside the cone?
1/3.
1/3. 1/3 of the cylinder fits inside. All right. Okay, so that just reinforces here. This is the exact same formula as before, where we had 1/3 area of the base times the height. The only difference is, hey, what shape is our base?
Circle.
It's a circle. And our base is a circle, so to find the area of that circle, it is pi radius squared. All right, and so we put the 1/3 in front and the height at the end, and that is where this formula comes from. So it's not any different. But it is one that is very common, and we have to use a lot in higher math. So that's definitely one you want to know. God bless you. So this one's very nice. Let's start with number 8. What is the radius on number 8? 2.5, half of 5. Very good. And what is the height?
8.
8. The height of the cone is 8. And so to find volume, it is 1/3 pi radius squared times height. Pi times 2.5 squared times the height of 8. 1/3 times pi times 2.5 squared times 8. 52.4 inches cubed. I'm not sure what they're going to ask for in Delta Math, whether it's going to be to the tenths or hundredths or thousandths. So pay attention. On number 9, what is the radius? 13.5. So 27 divided by 2 is 13.5. Ruh-roh. Pythagorean theorem, because we don't have the height of the pyramid. All right, we need to find the height, that very tallest height, and then I do know what is this lower leg of my triangle, 13.5. All right, and we have the slant height, 22.5. So we need the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So h squared plus 13.5 squared equals 22.5. So 22.5 squared. I have to subtract that 13.5 squared to move it to the other side. So I get h squared equals 324. And then I need to square root both sides. I get 18. So my height is 18. And now I can use my formula for volume. Volume equals 1/3 pi times my radius squared times my height of 18. All right, 1/3 times pi times my radius. Oh, you know what? I'm just going to use parentheses. 13.5 squared times a height of 18. So 3435.33. I like that. Kilometers cubed. All right. Do you guys have any questions for me? All right, sweet. And you guys have adult math today. 17 minutes. That was really pretty fast.